Hello friends, today in this lecture we will solve few numericals based on the properties of fluid. So let's start with our first question.
So what is given in the question? A plate 0.025 mm distance from a fixed plate moves at a 60 centimeter per second and requires a force of 2 Newton per unit area, that is 2 Newton per meter square, to maintain this speed. Okay, so it's a one sentence only. In that, what is given to us? The distance between the plate from a fixed plate. So that if I draw the diagram, it is something like that. So this is the fixed plate and this is the another plate, and the distance between these two plate is 0.025 mm. Okay, and this plate is moving with a velocity of 60 centimeter per second and requires a force of 2 Newton per unit area. Okay, so the force which is applied over here is 2 Newton per meter square. Here it is mentioned that requires a force of 2 Newton per unit area. So 2 Newton per unit area, area is meter square. So this is not the unit of force. So definitely this is a stress. So here it is a shear stress. So shear stress is given 2 Newton per meter square. Velocity V or U, anything you can write, it is given as 60 centimeter per second, and the distance between the moving plate and the fixed plate is given. Okay. Determine the fluid viscosity between the plates. Okay, so here we have a fluid. Okay, here we have a fluid and we have to find out the viscosity of this fluid. So what we have to find? To find viscosity of the fluid. Here it is not mentioned that we have to find kinematic viscosity or dynamic viscosity. In that case, always remember you have to find out dynamic viscosity only. Okay, so tau is given, velocity is given, and the distance between the plate is also given. So let's say this distance is y, 0.025 mm. By using Newton's law of viscosity, so we know that tau is equal to mu du by dy. Okay, so du is change in velocity. So here what will be du? Here with a 60 centimeter per second that fluid is flowing. So starting from 0, so 0 minus this, so change in velocity is 60 centimeter per second only. So change in velocity is 60 centimeter per second only. So that is equal to, convert this into meter per second, so 0.6 meter per second. And the distance between these two plates is dy only. So here I can write dy also or y also. This is the distance only. So dy is equal to 0.025 mm. So this is equal to what? 0.025 into 10 raised to minus 3. 0.025 into 10 raised to minus 3 meter. So it is always advisable कि आप SI यूनिट में कन्वर्ट करो, न्यूटन मीटर में, क्योंकि अगर मैं यहाँ पे सबको mm में या सेंटीमीटर में कन्वर्ट करता तो मुझे ये भी वापस कन्वर्ट करना पड़ता. So better convert everything into meter only. So कितना आ रहा है म्यू का वैल्यू? So 2 as it is, mu which we have to find out, du is 0.6, dy is 0.025 into 10 raised to minus 3. Solve this and tell me mu का वैल्यू कितना आ रहा है? My value is 8.33 into 10 raised to minus 5 Newton second per meter square. If I want to write this in terms of poise, so क्या आएगा mu का value? 1 poise is equal to, क्या था हमारा convergence? 1 poise is equal to 1 by 10 Newton second per meter square. So this multiply by 10, 8.33 into 10 raised to minus 4 poise. Determine the intensity of the shear of an oil having viscosity is equal to 1 poise. So viscosity is given 1 poise. The oil is used for lubricating the clearance between the shaft of a diameter 10 centimeter. Diameter is given. So here velocity is the angular velocity. So angular velocity we measure in radians. That's why you have to use omega. Diameter 10 centimeter. The clearance is 1.5 mm and the shaft rotates at 150 rpm. So rpm is given. So you have to convert this rpm into velocity. You have to convert this rpm into velocity. Here your velocity is angular velocity. तो पहले आपका angular velocity को आपको convert करना है linear velocity में. Okay, so omega is equal to 2 pi n to 60. With this you can get the angular velocity. Okay, and if you want to convert this angular velocity into linear velocity, you have to use the formula v or u is equal to r omega. So if I put the value of omega in this equation only, so r into 2 pi n divided by 60. So this is equal to 2r is equal to d. So pi dn by 60. So here velocity you can find out with this formula. This is equal to velocity u.
Let's solve this.
So determine the intensity of shear of an oil having viscosity is equal to 1 point. So what we have to find? So first, always while solving the numericals, you have to put all the given data on one side and what you have to find, so that ये एक बार data आ गया कि हमको बार बार ये question को तरफ देखने की जरूरत नहीं. Okay, so we have to find tau. Shear stress we have to find. Having a viscosity is equal to 1 poise. So dynamic viscosity is given 1 poise. Definitely this is not the काइनेमेटिक विस्कोसिटी, क्योंकि काइनेमेटिक विस्कोसिटी पॉइस में मेजर नहीं होती है, वो स्टोक में होती है या फिर मीटर स्क्वायर सेकंड में होती है. सो हियर म्यू इज इक्वल टू 1 पॉइस. ओके, एज इट इज हम ये पॉइस को भी यूज नहीं कर सकते क्योंकि ये सीजीएस यूनिट है. हमको आगे सेंटीमीटर आरपीएम मतलब न्यूटन में हम कुछ ऐसा यूनिट में हम बात करेंगे. सो कन्वर्ट दिस. सो 1 पॉइस इज इक्वल टू 1/10 न्यूटन सेकंड पर मीटर स्क्वायर. So mu का वैल्यू दिया है 1/10. The oil is used for the lubricating the clearance between the shaft of a diameter 10 centimeter and its journal bearing. So अगर आपको नहीं समझ में आया ये, तो ये journal bearing है, उसके अंदर ये shaft है और इनके बीच में lubricating oil है. बस इससे ज़्यादा समझने की अभी ज़रूरत नहीं. तो diameter of the shaft is given to you. Diameter of the shaft is 10 centimeter. Okay, and oil is used for a lubrication. The clearance is 1.5 mm. The distance between this and this is 1.5 mm. So dy or y I can write is equal to 1.5 mm. This is the distance between the two surfaces where the oil is there. So dy is equal to 1.5 mm. So also I have to convert this into meters. So 1.5 into 10 raised to minus 3 meter. This is also 10 into 10 raised to minus 2 meter. Okay, now you have all the values. RPM is also given to us, which is 150 RPM. So first you have to find out the velocity, and with the velocity and with this Newton's law of viscosity you can find out the answer. So यहाँ पर आपके पास velocity नहीं है. So to find out this velocity, we are going to use this formula pi dn by 60. ये formula कैसे आया ये भी मैंने आपको बताया. Omega is 2 pi n by 60. Unit is radian per second. This is the angular velocity, and to convert this angular velocity into linear velocity we use the formula r omega. So omega का वैल्यू मैंने यहाँ पर ही डाला और ये 60. Therefore u is equal to pi dn by 60. Okay, so with this you can find out u. Now you know the value of u. Change in velocity is u only, because 0 से start करेंगे. Initially there was no rotation of the shaft, and after that the rotation has started and reach up to 150 rpm. So change in velocity is the final velocity only. So u is nothing but a change in velocity du only. Now just put the value and you can get the value of tau. कितना आ रहा आंसर? 2.33. Newton per meter square. Let's see few more questions. Yes, write down this question. So calculate the dynamic viscosity of an oil which is used for lubrication between a square plate of a size 0.8 meter by 0.8 meter. Okay, so area of the plate is given. Okay, so area, I will write area of the plate is 0.8 meter by 0.8 meter. Again, this is given data. So this is 0.64 meter square. Calculate the dynamic viscosity of an oil. So what we have to find? Dynamic viscosity. Viscosity of oil which is used for lubrication between the square plate of size this and the inclined plane with the angle of inclination 30 degree. If I draw the diagram, then it is something like this. So this is, let's say, the inclination of 30 degree, and here we have a square plate. This is the square, and here between the square plate and this inclined surface we have a lubrication. I have already drawn this figure. The weight of the square plate is 300 Newton. So weight of the plate W is given, which is 300 Newton. So here the force is given, but that force is inclined force. So if I draw the force over here, so this is the weight W, it is acting like this, and it slides down the inclined plane with the uniform velocity of 0.3 मीटर पर सेकेंड. इट स्लाइड्स डाउन, तो ये नीचे के साइड में जा रहा है और इसका वेलोसिटी भी दिया है. सो u इज गिवन टू अस विच इज 0.3 मीटर पर सेकेंड. The thickness of the oil film is 1.5 mm. So this thickness is also given. So what is this? Y or dy? Thickness is given 1.5 mm. So unit सबके check कर लो. So this is 1.5 into 10 raised to minus 3 meter. Okay. Now how to find out mu? Again the same formula. Tau is equal to mu du by dy. We have to find out mu. Tau का वैल्यू दिया है, tau is not given, so we have to calculate this. u का वैल्यू पता है हमको और y का भी वैल्यू पता है. So u and y is known to us. Tau we have to calculate. So how to find out this tau? Tau is nothing but a shear stress. So shear stress का फॉर्मूला क्या है हमारा? फोर्स अपॉन एरिया. एरिया हमको पता है, this 0.64. What about the force? Force is the weight 300. Can I write 300 here? No. 300 कब लिखता था? जब ये हॉरिजॉन्टल रहता था. ये इंक्लाइंड है अभी. इट इज मेकिंग एन एंगल 30 डिग्री. सो यहाँ पर ये 300 डिग्री नहीं रहेगा, यहाँ पर रहेगा 300 साइन 30 डिग्री. सो इफ यू वांट, मैं यहाँ पर थोड़ा और इसको एक्सप्लेन करता हूँ. सो दिस वे योर फोर्स इज एक्टिंग. This is 30 degree and this is force. So from this you can find out W is equal to 300 Newton. So यहाँ पर अगर मैं ड्रॉ करता हूँ तो कुछ इस तरीके से ड्रॉ होगा. Two forces, two components of the force. You have studied this in mechanics, engineering mechanics, right? So 300 sin 30 I can write, or I can write 300 cos 60. So 300 cos 60 is also okay upon 0.64. So from this you can get the value of tau. So mu is equal to tau upon du by dy. So tau I have taken 300 sin 30 upon 0.64 upon change in velocity 0.3 upon this 1.5 into 10 raised to minus 3. Solve this. Yes, 1.17 Newton second per meter square. And in terms of poise, if I want to write, so multiplied by 10, so 11.7 poise. The next question. So what is given in this fourth question? Two large plane surfaces are 2.4 centimeter apart. Okay, there are two large surfaces and the distance between that two surfaces is 2.4 meter apart. The space between the surface is filled with the glycerin. What force is required to drag a very thin plate of a surface area 0.5 meter square between the two large plane surface at a speed of 0.6 meter per second? So we have two large surfaces. If I draw the diagram, this is the first surface and this one is the another surface. So these are the two large surfaces and the distance between these two fixed plate is 2.4 centimeter. यहाँ पर क्या है? Glycerin. This is filled with the glycerin. What force is required to drag a very thin plate of a surface area 0.5 meter square? So यहाँ पर कहीं पर plate है. Let's assume this is a very thin plate and the area of this plate is given. So I will write area of the plate, suffix if you want, you can add plate. This is 0.5 meter square. This distance 2.4 is what you can write it down directly here. The distance between two surface is equal to 2.4 centimeter. Now what we have to find? What force is required to drag a very thin plate? So we have to find a force. We have to find a force to drag this very thin plate of area 0.5 meter square between the two large plane surface, okay, at a speed of 0.6 meter per second. So velocity is given. Velocity of the plate is 0.6 meter per second. Now there are two conditions. If the first condition is that the thin plate is in the middle of the two plane surface. So condition one is plate is at the middle. So when the plate is at the middle, how much force is required, that I have to calculate. And the second thing is the thin plate is at a distance of 0.8 centimeter from one of the plane surface. Take the dynamic viscosity of the glycerin is this. So dynamic viscosity is given Newton second per meter square. And in the second case, the distance from any one plate is 0.8 centimeter. So I will write distance from one plate, any one plate is 0.8 centimeter. Okay, so first we will talk for this first condition. First I have to find out tau, and we know that tau is equal to force upon area. So force is equal to tau into area. The unit for this is Newton per meter square. This is Newton. This is Newton per meter square into meter square. So meter square get cancelled. So we will get the Newton. Okay. So with this, I am going to find out the force. So to find out the force, first I have to find out tau. Here we have the dynamic viscosity is equal to du by dy. So with this formula, I am going to find out tau, and once I get the tau, I am going to multiply it with the area. Area is given to me, so I can get the force. Now for first condition, plate is at the middle. So this distance is 1.2 centimeter. And this distance is 1.2 centimeter. Now this is your y. This is not y. 2.4 centimeter is not y, because we are calculating the shear force along this plate and this surface from one side, और दूसरे side में भी calculate करेंगे. So what I have to do, I have to find out shear stress for this upper plate, then shear stress for lower plate, and combinedly I have to take the value of this tau to find out the force. So मुझे tau 1 find out करना पड़ेगा, फिर tau 2 find out करना पड़ेगा. Okay, so we will start with the first case. Okay, so case 1, y is equal to, or dy is equal to 1.2 centimeter, which is 1.2 into 10 raised to minus 2 meter square. Okay, so I have to find out tau 1. So tau 1 is equal to mu into du by dy. So what is the value of the mu? 8.10. So 8.10 into 10 raised to minus 1, this is viscosity multiplied by change in velocity. How much change in velocity? 0.6. 0 to 0.6 हो रहा है वो. So change in velocity is 0.6 meter per second only. And dy is 1.2 into 10 raised to minus 2. Calculate this and tell me कितना आ रहा है shear stress 40.5 Newton per meter square. So that much shear stress is on the upper side of the plate. इतना shear stress कहाँ पर लग रहा है? ये अपर साइड ऑफ द प्लेट. हम अपर साइड का फाइंड आउट कर रहे हैं. तो यहां से इतना जो यहाँ पर ग्लिसरीन है उसकी वजह से जो शेयर स्ट्रेस लग रहा है यहाँ पर ऊपर के साइड में इज दिस मच 40.5. सो नाउ फ्रॉम दिस इफ आई वांट टू कैलकुलेट F1, सो F1 क्या आएगा? F1 इज इक्वल टू टाउ 1 इनटू एरिया. तो टाउ 1 इज 40.5 इनटू एरिया विल बी 0.5. कितना आ रहा है ये? 20.25 न्यूटन. सो इतना फोर्स ऊपर के साइड से लग रहा है उसको टू ड्रैग दिस एट दिस वेलोसिटी 0.6 मीटर पर सेकंड. ये वेलोसिटी से उसको खींचने के लिए ऊपर के साइड से मुझे इतना फोर्स चाहिए. लेकिन नीचे के साइड भी मुझे काउंट करना पड़ेगा क्योंकि नीचे भी वहां पर शेयर फोर्स आएगा, शेयर स्ट्रेस आएगा. सो नाउ हाउ टू कैलकुलेट दिस? अगेन बाय सेम मेथड. बट डू यू थिंक कि हमको ये वापस कैलकुलेट करना चाहिए? नो, बिकॉज प्लेट मिडल में है उसकी वजह से y का भी वैल्यू चेंज नहीं हो रहा है, u का भी वैल्यू चेंज नहीं हो रहा है, म्यू का भी वैल्यू चेंज नहीं हो रहा है. अगर ये तीनों सेम ही वैल्यू है तो टाउ 1 भी वही आएगा, एरिया भी चेंज नहीं हो रहा है तो फोर्स भी वही आएगा. सो द टोटल फोर्स आई कैन डायरेक्टली राइट हियर, टोटल फोर्स रिक्वायर्ड टू ड्रैग द प्लेट is F1 plus F2. Now F2 you can understand. Okay, दोनों का वैल्यू सेम ही रहेगा 20.25 plus 20.25. So 40.5. This is equal to 40.5 Newton total force. So now let's see the case 2. Now in case 2, what is given to us? From any one plate, the distance is 0.8 centimeter. So if I draw the diagram again here, so these are the two plates and now this plate is somewhere here. Okay, now this distance is 0.8 centimeter. I have to calculate ये कितना है. मुझे ये टोटल पूरा पता है 2.4. यहाँ पर again we have a glycerin only. And I have to find out the force. So अगर ये 0.8 है, 0.8 सेंटीमीटर है, टोटल मुझे 2.4 सेंटीमीटर दिया है, तो ये कितना होगा? 1.6 सेंटीमीटर. So tau 1 is equal to mu du by dy. So 8.10 into 10 raised to minus 1 into 0.6 अपॉन, मैं ऊपर के प्लेट के लिए पहले फाइंड आउट कर रहा हूँ, तो 0.8 into 10 raised to minus 2 सेंटीमीटर. सो यहाँ से मुझे मिलेगा टाउ 1 60.75 न्यूटन पर मीटर स्क्वायर. Multiply it with the area, you will get the F1 30.37. सो ये हो गया F1. सो F1 मतलब ऊपर के साइड से जितना शेयर फोर्स चाहिए वो हमने कैलकुलेट कर लिया. सिमिलरली आई हैव टू फाइंड आउट फ्रॉम द डाउन साइड ऑफ द प्लेट. सो टाउ 2 इज इक्वल टू म्यू du by dy again. So 8.10 into 10 raised to minus 1 into du is same 0.6 and this will be 1.6 into 10 raised to minus 2. Tell me tau 2. 30.375. Okay, multiplied by area, 15.18. So total force required is equal to F2 is equal to 45.556 Newton. So that much force is required. So पहले जब प्लेट मिडल में था तब 40.5 लग रहा था फोर्स, और अभी प्लेट का सिर्फ पोजीशन चेंज किया, ग्लिसरीन वही है, स्पीड वही है, एवरीथिंग इज सेम, ओनली द पोजीशन इज चेंज, तो यहाँ पर फोर्स ज्यादा लग रहा है, मतलब मिडल में फोर्स रिक्वायर्ड जो है वो कम रहेगा. So quickly we will say this. Determine the bulk modulus of the elasticity of a liquid. If the pressure of the liquid is increased from 70 Newton per centimeter square to 130 Newton per centimeter square, means P1 and P2 is given. Given data I am writing here. P1 is initially it is 70 Newton per centimeter square, and after that by applying a pressure increase the pressure up to 130 Newton per centimeter square. Okay, the volume of the liquid decrease by 0.15%. Volume is decrease, so decrease in volume is equal to how much? 0.15%. Here what I have to find? I have to find out bulk modulus, which is K. Okay, so how to find out K? Compressive stress upon volumetric strain. 70 minus 130, 60. 60 is the compressive strain. And what will be the volumetric strain? What I can write here? Volumetric strain में यहाँ पर ये जो वॉल्यूम है इसको मैं चेंज इन वॉल्यूम है, सो इसको मैं लिख सकता हूँ 0.15 डिवाइडेड बाय 100, मतलब ये हो गया ओरिजिनल वैल्यू एंड दिस इज द चेंज वॉल्यूम. सो डीवी बाय वी के फॉर्म में मैं लेके आ गया इसको. ओरिजिनल इतना था, बाद में ये इतना डिक्रीज हुआ, इतना चेंज हुआ, राइट. सो दिस इज द वॉल्यूमेट्रिक स्ट्रेन, सो आई कैन राइट इट हियर 0.15 upon 100, and if I solve this I can get the value of K.
4 into 10 to the power 4.
Correct. Newton per centimeter square, the value of K.
Please like, share and subscribe if you like this video.